As we gaze upon the stunning beauty of the night sky, we can't help but wonder what secrets the universe holds. Among the many wonders of the cosmos, one of the most captivating and awe-inspiring is the nebula. A celestial masterpiece of interstellar gas and dust. Nebulae are often referred to as stellar nurseries, as they serve as the birthplace of new stars. Within these vast clouds of gas and dust, we can witness the very building blocks of the universe at work. Each nebula is a unique and breathtaking canvas of cosmic art, displaying a dazzling array of colors and shapes that have captured the imaginations of astronomers and stargazers for centuries. So, let's explore some of the most spectacular and fascinating examples of our galaxy's nebulae, delving into their history, structure, and the incredible phenomena that occur within them. Join me on this journey of wonder and discovery, as we explore the mysteries of our universe's most enchanting creations. Nebulae, vast and magnificent, are scattered throughout our galaxy and beyond, a lasting legacy of the formation of stars. These interstellar clouds contain the raw materials to create new stars and planetary systems. They are composed of many different substances, but the primary elements in these clouds are hydrogen and helium, the two lightest elements in the universe, along with trace amounts of heavier elements like carbon, oxygen, and nitrogen. It is these elements that form the ingredients for the creation of new stars and planets. Intricate and varied, nebulae come in many different shapes and sizes. From the loose and shapeless to the highly structured and ornate, the shapes of these clouds are determined by the interplay between gas and dust within them, as well as the energy input from nearby stars and other cosmic phenomena. Iconic examples of these spectacular formations include the Horsehead Nebula, the Crab Nebula, and the Ring Nebula, each with its own unique morphology and history. The study of nebulae is essential to the understanding of star formation and the evolution of galaxies. By observing the composition and structure of these clouds, astronomers can gain insight into the physical conditions and chemical processes that govern the formation of these celestial bodies. In short, nebulae are some of the most fascinating and scientifically significant objects in the universe, and their exploration continues to unravel the mysteries of our cosmic origins. Although modern telescopes can give us breathtaking close-up views of the nebulae in our galaxy, even the earliest astronomers found their imaginations captured by the bright and beautiful clouds, and the history of their study dates back to the early days of telescopic observation. As the 18th century dawned, astronomers were just beginning to explore the world beyond our solar system. Armed with primitive telescopes and a curiosity about the mysteries of the night sky, they sought to discover the wonders of the universe. One of their primary targets? Comets. Comets were thought to be of great astrological significance, harbingers of change and omens of fortune. But the presence of many nebulous objects, which appeared fuzzy and indistinct through the early telescopes, often made it difficult for astronomers to distinguish comets from other objects. Enter French astronomer Charles Messier. An avid comet hunter, he began compiling a catalogue of nebulous objects in 1760. His goal was to aid in the search for comets by making a comprehensive list of these objects. Over the next several years, he catalogued over 100 of them. Messier's catalogue included many objects that we now know to be galaxies, but it also contained a number of true nebulae, including both the Orion and the Crab Nebulae. While he originally thought that all of these objects were clouds of gas and dust within our own galaxy, his work paved the way for later astronomers to study these objects in more detail. One of the most influential astronomers of this era was William Herschel. Born in Germany in 1738, Herschel moved to England in his early 20s and made his living as a professional musician. But his real passion was astronomy, and with the help of his sister, Caroline, he soon began building his own telescopes to study the night sky. Herschel's telescopes were far more advanced than those of his contemporaries, allowing him to observe the heavens with unprecedented clarity. Using these powerful telescopes, he observed the objects in Messier's catalogue, and discovered that many of the objects that had been listed as nebulae were actually star clusters that looked hazy with poorer magnification. He eventually published his own catalogues, meticulously recording thousands of nebulae. Herschel's work was instrumental in advancing our understanding of these cosmic phenomena. He observed that some of the objects he found had highly structured forms, and he proposed that they were not simply clouds of gas and dust, but rather vast collections of stars too far away to be seen individually, what we now know as galaxies. Herschel's work inspired generations of astronomers to study nebulae in more detail, and his catalogue of nebulae and star clusters became a vital reference for astronomers well into the 20th century. With their vast, swirling clouds of gas and dust, glowing with colors that seem almost otherworldly, it is no wonder that nebulae attracted the attention of astronomers. These enigmatic objects, scattered throughout our galaxy and beyond, may look similar at a glance, but their true nature is as diverse as it is stunning. From massive, star-forming clouds to the remnants of supernovae, each variety of nebula has its own unique properties, origins, and place in the grand tapestry of the cosmos. In the late 1800s, more advances in telescope technology allowed astronomers to observe nebulae in even greater detail. They made the surprising discovery that they were able to divide nebulae into different categories, paving the way for a more detailed understanding of the physical processes that govern them. One of the earliest classifications was planetary nebulae. Planetary nebulae are one of the most famous types, and get their name from their round planet-like shape. Despite their name, they have nothing to do with planets. Rather, they are formed in the death throes of stars like our Sun. As these stars near the end of their lives, they undergo a series of violent convulsions that cause them to shed their outer layers of gas and dust. These layers are then illuminated by the intense ultraviolet radiation from the dying star's core. As the outer layers of the star are blown away, they form a glowing shell of gas and dust that can be illuminated by the central star, creating a stunning display of colors and intricate structures. These nebulae are often symmetrical, but many have complex shapes influenced by anything unlucky enough to orbit the star when it dies. Planetary nebulae may have multiple shells, jets, or lobes, creating intricate and mesmerizing patterns. These shapes come from the specific movement of gas winds emitted by the dying star at their center. The winds can be stirred and mixed by any orbiting companions, such as smaller stars or massive planets, resulting in unique shapes that eventually grow and evolve into impressive configurations. Planetary nebulae are a type of emission nebula, which means the ionized gas they are made of is glowing, emitting its own light in various colors. A stunning example of a planetary nebula is the Butterfly Nebula, located about 3,800 light-years away, in the constellation Scorpius. The Butterfly Nebula is known for its complex and intricate structure, with two bright lobes of gas and dust extending out from a central star. It gets its name from its striking resemblance to a butterfly with its wings spread wide. This nebula formed from the remains of a dying star that was once 5 times the mass of our Sun. The glowing gas of the nebula is what is left of the star's outer layers, which were expelled thousands of years ago, and the star continues to unleash a stream of ultraviolet radiation that makes the ejected material glow in vibrant colors. The star in the center is obscured by a donut-shaped ring of dust, which appears as a dark band pinching the nebula in the middle. The thick dust belt constricts the star's outflow, creating the hourglass shape. The wings of the Butterfly Nebula stretch more than 3 light-years wide. Its colorful appearance is due to the presence of different elements within the gas and dust, including nitrogen, hydrogen, and oxygen. The blue color comes from ionized helium and hydrogen, while the red comes from ionized nitrogen. While planetary nebulae may be among the most beautiful and recognizable types of nebulae, they are also incredibly rare. they represent only a brief phase in the life of a star, lasting just a few thousand years before the central star cools and fades away. Nonetheless, the study of planetary nebulae has helped us better understand the complex processes that occur during the late stages of stellar evolution. But not all emission nebulae are formed by dying stars. Some are just the opposite. Star-forming regions, also known as stellar nurseries, are areas of space where massive interstellar clouds of gas and dust are contracting, and things are getting hotter. These regions, sometimes called giant molecular clouds, are the perfect place for new stars to form. Gradually constricting under their own gravity, these clouds eventually become dense enough to collapse. As the clouds collapse, they heat up. And at the center of this hot, dense ball, a protostar is born. A protostar is a cosmic embryo, a tiny seed that has the potential to grow into a brilliant, shining star, the first step in the process of stellar evolution. As the protostar grows, it draws in more and more material, building up mass until it becomes hot and dense enough to ignite nuclear fusion at its core. The energy released by this process creates a dazzling display of light and heat, transforming the little protostar into a full-fledged star. Stellar nurseries are often found in the spiral arms of galaxies, where the density of gas and dust is higher than usual. They can also be found in regions where stars have recently exploded as supernovae, as the explosion can trigger the collapse of nearby molecular clouds. One of the most well-known stellar nurseries is the Orion Nebula, located in the constellation Orion. A spectacular display of interstellar gas and dust, this celestial wonder is a bustling center for the creation of new stars, with as many as 1,000 in the process of taking shape there. About 1,300 light-years away from Earth, this nebula is visible to the naked eye as a fuzzy patch in the night sky, and it is a popular target for both amateur and professional astronomers. As we approach the nebula, we can see that the gas is not uniformly distributed. Instead, it is clumped into bright regions, where the gas is ionized by the intense radiation of nearby stars. This is where new stars are being born. Still closer, we see that the gas and dust is swirling and churning. This chaotic motion is caused by the powerful winds created by radiation from the young, massive stars within the nebula. Many of the young stars are surrounded by protoplanetary disks, which contain the raw materials that will eventually form planets, moons, and asteroids. The heart of the Orion Nebula holds a cluster of massive stars, known as the trapezium, whose intense radiation and stellar winds sculpt and shape the surrounding gas and dust into intricate and beautiful patterns. But the Orion Nebula is more than just a beautiful spectacle. It's a vital laboratory for the study of star formation, and a place where astronomers can witness the birth and evolution of stars firsthand. By studying the Orion Nebula, scientists can gain insights into the processes that shape the cosmos and unlock the secrets of the universe itself. From these massive and turbulent stellar nurseries, where new stars are born and the cycle of cosmic life continues, we now shift our focus to another kind of nebula, one that marks the explosive end of a massive star's life. As stars that are much more massive than our Sun reach the end of their lives, they may explode in a violent supernova, unleashing enormous amounts of energy and scattering their material into the surrounding space. The remnants of these explosions create some of the most striking and intriguing nebulae in the sky, offering a glimpse into the fiery deaths of these stellar behemoths. Known as supernova remnants, these glowing clouds of gas can last for thousands of years. Rich sources of energy, they blast out shockwaves into the surrounding interstellar medium, creating expanding shells of gas and dust. As these shells move outward, they collide with the surrounding gas, causing it to heat up and glow brightly. The intense energy and radiation from the explosion also ionizes the gas, causing it to emit light in a process similar to that of stellar nurseries. This creates the beautiful and colorful structures that we see in many nebulae formed of supernova remnants. The elements that were formed in the heart of the star are also released into the surrounding gas during a supernova explosion. These elements, such as carbon, oxygen, and nitrogen, play a critical role in the formation of new stars and planets. Without the death of massive stars in supernova explosions, the universe as we know it would not exist. The stunning beauty of nebulae formed from supernova remnants is a testament to the powerful forces at work in the universe. But it also reminds us of the fragile nature of our existence and the deep connection between life on Earth and the universe beyond. An exciting example of a supernova remnant is the Crab Nebula. One of the most well-known and studied objects in the night sky. It is located in the constellation Taurus, about 6,500 light-years away from Earth. The nebula was first observed by Chinese astronomers in 1054 AD. They recorded the appearance of a bright, guest star in the sky. The star was visible to the naked eye for several weeks, and then faded from view. Today, we know that the bright object they saw was actually a supernova explosion. In 1731, the English astronomer John Bevis rediscovered the Crab Nebula while searching for a comet. He noted that the object appeared as a faint nebula surrounding a central star. In 1758, the French astronomer Charles Messier included the Crab Nebula as the first entry in his famous catalogue of nebulous objects, listing it as a nebula without a star. It wasn't until the early 20th century that the true nature of the Crab Nebula was fully understood. In 1912, American astronomer Vesto Slipher discovered that the nebula was expanding at a rate of about 1,000 kilometers per second, indicating that it was the remnant of a massive explosion, a supernova. Today, the Crab Nebula remains an important object of study for astronomers, providing insights into the life and death of stars, the formation of nebulae, and the behavior of extreme objects like pulsars. Its historical significance as one of the first recorded supernovae also makes it of particular interest to scientists. Not all nebulae are formed from the aftermath of such violent events. Some are created by the gentle reflection of light on interstellar dust, giving rise to some of the most striking and ethereal objects in the night sky. Reflection nebulae. Let's take a moment to delve into the secrets of these celestial wonders. Unlike emission nebulae that emit their own light, reflection nebulae are made up of clouds of gas and dust that scatter the light from nearby stars. The blue color we often associate with these nebulae is due to the fact that blue light scatters more easily than other colors. In fact, this is the same reason why our sky appears blue during the daytime. One of the most famous examples of a reflection nebula is the Witch Head Nebula, located in the constellation Orion. The nebula's distinctive shape resembles the profile of a witch's head, hence the name. The nebula is illuminated by the star Rigel, one of the brightest stars in the night sky. While reflection nebulae may not emit their own light, they are still important objects to study in astronomy. By observing the way the light is scattered, we can learn more about the properties of the dust and gas that make up these nebulae. Additionally, studying these nebulae can also give us insight into the properties of the stars that illuminate them. But not all nebulae shine brightly. In the vast expanse of space, there are regions that are shrouded in darkness. Known as dark nebulae, they are fascinating to scientists and stargazers alike. Unlike their luminous counterparts, dark nebulae are almost entirely invisible to the naked eye, appearing as black voids in the night sky. The only reason we can see them at all is that they are often silhouetted against a bright background of stars or emission nebulae. These interstellar clouds, made of dense molecular material and dust, are so thick that they obscure the visible light of objects behind them, creating black patches against the backdrop of the Milky Way. Dark nebulae are most commonly found near regions of active star formation. But what lies within these murky depths, hidden from our sight? In order to better understand these cosmic phenomena, scientists use a variety of tools and techniques. One of the most effective methods is to observe dark nebulae in the infrared part of the spectrum. Infrared light is able to penetrate the thick clouds of gas and dust, allowing scientists to peer inside and study the processes that are occurring within. One famous example of a dark nebula is the Crab Nebula, which is located in the southern constellation of Crux. It is one of the easiest dark nebulae to observe, even with the naked eye, as it appears as a large, dark patch against the starry background of the Milky Way. The Crab Nebula is believed to be around 600 light-years away from Earth, and measures about 30 light-years across. Its dark appearance is caused by the dense interstellar dust it contains, which blocks visible light from passing through it. Each type of nebula has its own unique properties and characteristics, and together they provide a fascinating window into the processes that shape our universe. By studying these objects, astronomers can learn about everything, from the life and death of stars, to the formation of galaxies and the evolution of the universe itself. And with new telescopes and observatories being developed all the time, there is no telling what new discoveries await us in the wonderful world of nebulae. If you enjoyed this video, please like and subscribe to my channel so that you won't miss a thing. There's more fascinating content coming your way all the time. Thank you.